In this video, we'll talk about stemming and lemmatization. Stemming and lemmatization are both text processing techniques in natural language processing that remove suffixes from inflected word forms to produce a root form. The goal of stemming and lemmatization is to simplify the words to standard words, which helps improve the performance of information retrieval, text classification, and other NLP tasks. So, the main difference between stemming and lemmatization is the form of the generated stem. In this, in stemming, the output is known as stem. It is generated by removing the common suffixes from English words. For example, if a word ends in ed, the ed is removed. So the stem may not be actual word. For example, let's take a word like them. Here, stemming does remove the ed from the given word and the output stem is jump. So now in NLTK, we have an algorithm called Porter stemmer, which does the stemming for us. Let's import the Porter stemmer. Try to stem the word rain. So Porter stemmer is a suffix stripping algorithm that removes common morphological endings or suffixes from English words to obtain the stem. So here in this case, it actually contains a dictionary with all the suffixes like ed, s, ing, etc. So when we run this method stem, the suffix ed has been removed. We'll take another example line. Here, the word lying, in this word lying, the suffix ing has been removed and the stem has been fixed. See another example. Yeah. And here the suffix t has been removed from run. So one thing that we need to take into consideration is that the stem may not be actual word. It may not be meaningful. So for that reason, we'll have another concept called lemmatization. So lemmatization, in lemmatization, the output is known as lemma. Lemmatization actually reduces the word to their base form or the root form. Lemmatization is more accurate than stemming, but can be computationally more expensive than stemming. And the lemma is a meaningful word. So to ensure that the lemma is the base form, we'll use WordNet, which you can treat it as a WordNet is like an English dictionary which contains all the meaningful words in language English. So we use NLTK WordNet lemmatizer to do the stuff for us. First, let's import the WordNet lemmatizer. Create a function. what all the things that we have in. So here we have a method called Lematize that that does lemmatization. That lemmatizes the word by using WordNet built-in function and returns the input word unchanged if it cannot be found in WordNet. Let's run it on an example. So this works similar to stemming, where it removes the ending s. Let's take another example runnable, where yeah. So where in the case of stemming, the suffix e has been removed. In the case of lemmatization, the lemma is the meaningful word that we find in WordNet. Let's take another example. Yes. So, but here in this case, for word fancier, fancy is the base word. But here the method lemmatized has provided us like generated the output fancier as the lemma. But it's not the case. So to resolve this, we need to provide POS tag of this of the given word. Here the parts of speech tag of fancier is adjective. So when we give an additional information about the given word, the lemmatizer would now understand that the given word is an adjective and there must be an another root word which is fancy here in this case. Similarly, we'll take another example. That is here it's of POS tag adjective. So here we got that sad is the lemma of the word saddest. Similarly, we can take many more examples. Let me copy and paste in here. Okay. Yes. So all the words jumping, jumps, and jump have been lemmatized to words. In this